Let's start with the next session of this course, where I will present a paper on need of blockchain written by Carl Woest and Arthur Gervais. Now, blockchain, already we are listening this from quite few days who are learners to this technology. We have understood that blockchain has been complemented as a technological innovation, and it has obviously changed the trends when it comes to society trades or some interactions. Why? Why we need blockchain? Because we have three M's here, because all of us are doing this blockchain course. So we have understood we have three M's, which forms the basis of blockchain. What are these three M's? Mutually mistrusting entities. So I'll take the third M as well in the coming like slides. So why we need blockchain? Because we have mutually mistrusting entities who want to exchange some financial values and also want to interact without relying on a trusted third party. So in addition to this, we also learned that blockchain provides integrity, protection of the stored data, and also it gives you process transparency, as shown by Arshdeep and Gagandeep in their demonstrations, in their lectures, where you can see the complete process and the complete mechanism can be viewed in terms of nodes, in terms of value, in terms of exchange, etc. So there is a complete process transparency. Now think for a while, if blockchain is an intended or I mean essential or appropriate technical solution for any specific application scenario, so we have to think upon this question as well. Why we have to use blockchain? Will it be appropriate for my application? Will there be any technical implications which I have to understand and I have to know before using this technology? Because now we have understood blockchain comes with the computational resource requirement, where we had to participate on this blockchain being a very resource filled participant. So we have to think upon this, whether we are doing right thing to adopt this blockchain for my application or not. Let's take a look first by recalling the concept of permissionless and permissioned blockchains, and then we will compare them to a central database. And after that, we will see the structured methodology which has been proposed by the authors, which is going to determine you the appropriate solution to solve a particular problem, followed by a discussion on some use cases. So for today's session, I'll be taking one use case of supply chain management so that I can make you understand what is the requirement and how the structured methodology towards the need of a blockchain can help you out. So when we say permissionless blockchain, so now we have also understood that let's start with traditional database in simpler terms. In databases, we have a writer. Writer is an entity which writes the states to the database, whether the transaction is committed, aborted, or whatever has been done between two accounts or two parties. So there is a writer who is going to write everything to the database. Now in blockchain, this writer means there is a participant. So writer actually corresponds to a participant in blockchain who is involved in consensus protocol and helps to grow this blockchain. So a writer accumulates the transactions within a block, and then the writer is going to append this block to blockchain. More specifically, we can call this writer as a validator if we are working on blockchains. Now with writer, we have readers as well in databases. Then we have reader as an entity who is going to just simply read the blockchain, who is going to analyze the blockchain, and who is going to like participate in transaction creation as well. So there is an entity who is just reading and who is not extending this blockchain. So we have readers and we have writers. So yes, the PPT is not changing. I'm very clear because today we'll be having 3-4 slides and I'll be taking from these slides itself. I'll make you understand the complete requirement of this blockchain. Don't worry about this. So I said we have readers and we have writers, right? So we have permissionless blockchain where we have to say that any peer can join anytime. He can leave the network anytime as reader or writer. Now we know what is a reader, what is a writer on blockchain. Reader simply going to create the transactions, not doing anything, just reading or auditing or something else. And writer is going to do more than that, growing your blockchain as well. So the peer can join on a permissioned blockchain. Any peer can join as reader or writer anytime. So there is no central entity there, right? So central entity, why we need a central entity? Because we need to maintain all the memberships. But on permission blockchain, there is no such central entity which is going to maintain the or manage the memberships. Even there is no central entity to check whether there is a legitimate user on this blockchain or not. So anyone can come as reader or writer on this blockchain, and anytime the peer can leave that blockchain. And we are not aware whether the writer or reader was a legitimate and authenticated user or not, a participant or not. So there is no such check in permission blockchain. Then why we have designed, or why the technology has been adopted past few years? Because we have cryptographic primitives we learned during the first day session, and these cryptographic primitives are sufficient and they are like feasible, makes the complete process technically feasible to design any permissionless blockchain. So the cryptography gives a lot of like the support towards the creation of a permissioned blockchain, permissionless blockchain, sorry. So permissionless blockchain, till now you have heard of Bitcoin, you have now worked upon Ethereum. So these two can be the right examples to quote for permissionless blockchain. We have Bitcoin, we have Ethereum as permissionless, where anybody anytime can join as reader or writer and then do some additions to the blockchain, or just create the transactions or read through the transactions. Now on the other side, we have a permissioned blockchain. Now this permission blockchain, which you are going to implement in the next upcoming session after the lunch break, I'll give you an example for that, the project we are going to implement. So first understand what is this permission blockchain. This has been recently proposed in literature. And why? Because we want to validate, we want to authorize some group of readers and writers. Now, similarly, we will have readers, writers on permissionless blockchain being a database. Now the readers and writers are going to be there, but these readers, writers are going to be validated, they are going to be authorized, and this will become a permissioned blockchain. So here we will have a central entity. Central entity is going to decide, and it is going to attribute all the rights to an individual peer to participate on the blockchain. That is, the participant can either read or write on this blockchain. So the widely used example for this permissioned blockchain is Hyperledger Fabric, and few of you have also worked upon R3 Coda as well. So we have these two very popular examples for permissioned blockchain. So you'll be doing this Hyperledger project in a complete sense in the next session by Gagandeep. So before moving to the structured methodology given by the authors, so I assume that you are aware of certain properties, important properties of blockchain, like you are listening to characteristics of blockchain in terms of transparency, in terms of privacy, in terms of reliability, and in terms of public verifiability as well. So where the public can come and verify, like on permissionless blockchain, it is the public who is going to validate or going to tell you that your transaction is verified, and now this block can be added to a blockchain. So yes, I can explain permissioned blockchain. Permissioned blockchain is being developed or is being designed recently, which where the main purpose is to validate and authorize some group of readers and writers. That is why the name permission. So we have to take permission from some uh, validators or authorized participants in order to get entered into a blockchain. So there will be a central entity basically who is going to validate, who is going to give the rights, who is going to give all the attributes to an individual peer to participate on this blockchain to read or write. So permissioned basically is used by the organizations the private organizations, or any organization can create their private blockchain, and then they can make it public by creating some permission rights to allow the validated and authorized user to their blockchain. So this is how permissioned blockchains they used to work. And as I said, Hyperledger Fabric is going to be explained in the next session, where you will have a complete view of permissioned blockchain. So as I said, you are aware of the properties, verifiability, transparency, privacy, and then you have integrity, etc. So though I understand that there will always be a tension between privacy and transparency, because yesterday I also heard this question from the participant about transparency and about privacy. So we have to know that this trade-off is always there when we work on any technology, because it depends upon the requirement of the technology or your application as well. See, privacy is definitely easier to achieve in central databases. So when you compare these blockchain with a central database, so we know that it's very like understood that privacy is easier to achieve, because there is no need of transparency there, and there is no need of verification as well, so that the system keep functioning, right? So that way we have to understand that privacy and transparency will always have this kind of trade-off always. Now, where does a blockchain make sense? You have to now answer this question, and you have to look for the solutions, the structured methodology you can use for this answer, for the answer to this question. Now in journal, if we see, the permissioned blockchain only makes sense where you have three M's. Again, I'll repeat: mutually multiple mistrusting parties. So already we started with mutually mistrusting parties, but here we have to add multiple as well. So these are three M's which makes the use of permission blockchain feasible. So we have multiple readers, writers who are mutually, they are going to do some mutual understanding. Based upon mutual understanding, they are going to do some work. And mistrusting, because they do not know each other, they do not trust each other, but somehow they have to interact with each other, and then they are not willing to agree upon an online trust party. So this is the journal scenario where you can use permissionless blockchain. So permissionless is going to work for multiple parties who are mutually agreed upon some process, some transactions, and then they are mistrusting. They do not trust each other, but they also do not want to rely on a trusted third party, and they want to change the state of the system as well. So they want to interact with each other, they want to change the state of the system, but do not agree to a third party. So that there we can use in journal the permissionless blockchain. Now, if we want to go for the specific solution towards this, so let us understand this structured methodology which has been presented by the authors, and we have to come to the specific solutions to know whether we need a blockchain or not. Now, let's start with the structured methodology. So here we have the first question: if there is no data, if there is no data which need to be stored, it means there is no need to store any state. Database means a state you want to store. So if there is no need to store the state of any transaction, it means you do not need a blockchain. So don't use blockchain in that case. But if we see the yes to this question, if we have states to the questions, then we have to move to the next component. The next question we have to answer when we have to store the states. So no data means no database, no data to be stored means no database required at all. which means that if you are using blockchain as a form of database, it will be of no use to you. Now, the next is when you have the multiple writers. Suppose you want to store the state. Now, you have a question if you have multiple writers or not. If it is not the case, it means that you have a single writer. There is only one writer. Now, what is the purpose of using a blockchain for one writer? That again makes blockchain infeasible to be used for the for single writer who want to store some state. So here also we will not use this blockchain. Now, if we have multiple writers, we have to answer our next question. Can you use an always online TTP? TTP is trusted third party. So we have to understand that if we are not going to store state, let me just repeat, if we are not going to store the states, we are not going to use blockchain. If there are no multiple writer, only single writer, we are not going to use this blockchain, because the regular database is much, much better, because it is going to give you better throughput in terms of lowered or minimal latency as well. So efficiency, throughput, latency wise, you can use the regular databases. Now, let us see this third question, this answer to this third question, where we have to answer if we are always using an online TTP or not. So if there is a trusted third party which is available, we have two options now. The two options is that the TTP is always available as online trusted third party. So if the answer is yes here, we need not to use blockchain, because the online available trusted third party. So what we can do, if it is always online, we can we can delegate all the write operations to this party, and this will function as a verifier for the state, for any kind of transitions, any kind of state transitions. So it means I do not need a blockchain in that case as well. So if I want to store state, if I have multiple writers, but there is always an online trusted third party who is available as verifier for all the state transitions. So in that case, I'm not going to use a blockchain, because the trusted third party is always there. So what the use of blockchain database to me? Now, if the trusted third party is like sometimes offline, right? So we have a party, trusted party, which is offline. So what the offline trusted third party is actually doing, it can, or it acts as, it can function as a certificate authority. So we can say that in the settings of permissioned blockchains, now we can have the certificate authority where we can rely upon. And then this if this is offline, we can have all the because all the writers, now we have to, if this is offline, first we have to answer this question: are all writers known? Which means that whether the writers who are writing on the system or the database, they are known to each other. If the writers here are mutually trusting each other, which means that they assume there is no malicious participant. So we can have a database with shared write access, which can be the best solution here. So this way we can see, we can work out to the permissionless blockchain if the writers are not known to each other. So as I said, in traditional databases or in blockchain, we have readers and writers, and they are they do not know each other. So if they do not know each other, they are mutually mistrusting parties, multiple parties, mutually mistrusting parties. It means we have to go to the choice of a permissionless blockchain. But if we have a trusted third party which is offline and serves as a certificate authority, where we will answer that we have some writers, and if these writers are known to each other, then we have to understand whether they are trusted third party, whether they are trusted writers or not, whether they are like validated, authorized users or not. So if they are verified users, all the writers are trusted, in that case also we need not to use a blockchain. But in case these writers, they are all not trusted, it means we need some public verification. which means the miners or the participants who are working on a blockchain are going to verify the transaction which has been done by the writers on that blockchain. So it means if we are doing this, we have entered into public permissioned blockchain. So we have a blockchain which is public permission. So we have two categories for permission blockchain here, public and private. And in case if there is no verification required, so we can enter into a private permission blockchain. So we know that everything because they have been an authorized user. So an organization has created a private permission blockchain where all the users who are going to read or write on that particular blockchain, they are all authorized, they are all validated by a certificate authority, and then all the writers are they have trust within each other. So we have entered into a private permission blockchain. So this is a complete structured methodology which has been proposed by the authors to understand which kind of blockchain we can enter into, or where we do not have to use this blockchain at all. So we can understand from this flow the complete methodology from where we have to use this blockchain, and if we have to use the blockchain, which category we have to enter into, either the permissionless blockchain or we have to enter into permissioned public as well as private blockchains. I'll explain this difference very soon. Let us cover up with this. So we'll take some queries. So we have some properties. Let's first, I think I should go to the properties which are going to compare, because now we know that we have central databases and we have permissionless and permissioned blockchain. So we can contrast some properties of these platforms and a central database. So centralized systems, we know that the performance in terms of latency and, as I told you, in terms of throughput, it is generally much better than in blockchain systems, because blockchains add the complexity, has additional complexity due to the consensus mechanism which is involved at the back end. For example, you have bitcoins. So bitcoins can have a throughput. Earlier it used to have a throughput in 2018. It used to have a throughput of only 7 transactions per second. So this was very like low in comparison to the central databases. And then we have the other trade-off between decentralization and other things. So we see throughput and latency is very high in central databases, and then latency in permissionless is slow, and then we have medium latency for permissioned blockchains. So these are some of the parameters upon which we are going to do this. But when we are making the decision of whether to use any blockchain system or not, so we can like take this trade-off as well into account, whether we are into the right direction of using a permissioned or permissionless or public permission or private permissionless blockchain or not. So there is always again a trade-off between decentralization as well, that how well your system is going to scale towards large number of writers, because scalability is a very a challenge, an issue in such platforms. So decentralization is going to have that issue as well. So without mutual trust and without like any good throughput from such systems, so we have to think upon this scalability trade-off as well. That is, how many states are going to update a system and into what amount of time we are going to do this or achieve this. So this we have to understand when we are using the blockchain. So we have some other properties where we can always compare these blockchains, centrally managed consensus mechanisms, and then we have number of untrusted writers, numbers of readers, writers, etc. So let us after knowing this structured methodology, let us take some use case which the authors have they have mentioned 3 to 4 use cases which you can go through in detail. So we'll share this research article with you as well on the database. So we'll take one use case from this. So which is a supply chain management. So let us take to that use case of supply chain management, and we will possibly evaluate the objectivity here, that how blockchain solution could take or could make sense, and what are the technical security and privacy implications when we are applying this blockchain into this supply chain management as well. So we have supply chain management where we all know the traditional chain there. We have flow of materials and services which is required to manufacture a given product. And this product has to be managed, which includes some intermediary like intricacies in terms of storage, in terms of production cycles, in terms of their delivery, in terms of transportation. So starting from the storage production cycles until to the delivery of the final product or the consumption. So this makes supply chain management or supply chain cycle to be complete. So where into the supply chain management, we have multiple companies. We have to know that these multiple companies interact with each other and they trade on a global scale. And this global scale is traded within a supply chain. So this is very, very complex, and the associated cost of managing all the inventory and all the processes, and if there is any kind of failure as well. So this becomes expensive sometimes for the business partners or the parties who are interacting with each other using this supply chain management system. Now in like existence nowadays, we have a lot of platforms which are blockchain based, and there are companies like I name Chain is there, Provenance is there. So these companies they advertise themselves to tell that blockchain based solutions are going to improve the efficiency of the complete supply chain management. So few of the like companies or the parties who are working on the supply chain management, they trust these companies and they try to adopt the solutions which are being provided by these companies in order to come to better efficiency and other things. But now what is there which we have to understand, how this is going to like make a difference when we have to use the technologies which have been like they have been designed by such companies or so. So as I said, Chain is one of the it's a company who provides blockchain solution, and it relies on Hyperledger. So Hyperledger Fabric, you will know. So Chain is working with the IBM Hyperledger Fabric, and it works as a blockchain backend. So what it do basically, it do some most of the supply chain managements, they do adopt this Chain technology. So whatever solutions, Chain solutions, but most of the time these companies like they overlook about the essential essential requirement of the blockchain. So for example, in the paper itself, the authors have claimed that this Chain only relies on a single source of truth. So though there are multiple parties, we have to understand in a blockchain, in a supply chain management, but as per Chain's policy, they trust only a single source of truth. And they said they claim that this is the single source of truth upon which we rely, and it is very, very sufficient. So we can trust a single database at Chain. It would be sufficient to satisfy all the business models or all the business needs. So we can see that at the back end, when these technological solutions, blockchain based technological solutions have been propagated by different companies like Chain or Provenance. So there are some hidden there are some hidden intricacies which we cannot trust fully. So we have to think in terms of technical feasibility, in terms of all feasibility when we are trying to use the solutions which have been given by these companies. Similarly, we have Provenance as well. So Provenance has some other they have some other things because they say that the data can be accessed and can be verified by all the actors according to their solution which they are proposing. So they does not provide any detail on their technical products, but always they are in the direction of claiming that no data, the data or everybody can access, and all the actors means we have readers, writers, or whosoever participate into a supply chain management cycle. So they are going to validate, they are going to access this, they are going to verify. So though they hide all the actors' identity, so readers, writers, or participants' identity can be hidden by provenance, but this could leak some amount of business critical information as well from different participants. Maybe somebody on the supply chain management can like they can leak the information related to the production, related to volume, and some time of production, etc. So these are some information which may be leaked from all the actors. So these are some of the like issues with these solutions which have been provided, and then we have to take care of the requirement at our side. What is our requirement, what is my application requirement, and accordingly I have to adopt a policy. And we have to look for each and every level of agreement, which we call service level agreements as well. So we have to look into all the details of these companies who are trying to provide this solution, which is blockchain based solution. So we'll not talk much in detail for, so I have quoted for SKU chain and provenance, which has been claimed by the authors as well, that those SKU chain and provenance are very highly adopted companies to provide a blockchain based or blockchain backend for the complete supply chain management. But there are hidden issues or intricacies with all the companies. So we have to take care of all these issues. Now, if we follow the, if we look at this diagram, we have a traditional supply chain management here, and we can see there is a blockchain powered supply chain management. So we know that traditional SCM is distributed, that there is no central entity, and the blockchain will maintain a distributed ledger on the other side, and every participant can update and pull the current state of this supply chain management. So this is how the traditional SCM and blockchain powered SCM looks like. Now we have to follow the methodology. We have understood a structured methodology. So how we are going to correlate that methodology into this supply chain management. Now, a supply chain management certainly requires something to store data, right? So it's certainly going to store the data. It means we need this blockchain based solution because we have something to store. If we start from this, if we start from here, if we connect our supply chain management use case to this methodology, so we know that SCM is going to require something to store. So we have multiple writers as well on the supply chain management. As I said, we have multiple parties here. So we have different participants of the supply chain management, and every participant will have their own share of the final product, which is going to come into the market. Now, SKU chain, as I said, it acknowledges to have only a single source of trust, though they do not like mention this in their agreements or so, but they need only single source of trust, which again I think removes the decentralized component of the blockchain, and it becomes equivalent to a trusted central server. So if we are using SKU chain, and SKU chain, if you are relying upon SKU chain, and SKU chain said that they rely on a single party or single trust party, it means that we need not to go for this blockchain based solution for our application if we are trying to rely upon that. Now if we continue this methodology, so SCM can have always an online TTP as well. So supply chain management could have this trusted third party which is online, and if it is not possible, so at least writers will be known to each other, because when we have a supply chain management, so into our supply chain management we have all the vendors, suppliers, so who are the growers, and everybody is there into the supply chain. So we know all the writers who are participating onto this. So it means now we have a question to choose between permissioned or no blockchain. So whether we want to go for a permissioned blockchain or not, and we are going to use, and we are not going to use blockchain at all. Now this reasoning can be like a question with all of us, whether all writers can be trusted or not as per this methodology. So why we have to question? Because when we have multiple writers, when we have online trusted third party, so we can we have to choose between this permissioned or no blockchain. Now we have to answer this, that if all the writers can be trusted or not. So on to supply chain management, what is the current or the inherent problem of any supply chain management here is the problem of interfacing between the digital world and the physical world. Because there is sometimes a human or some machine who is under the control of a single writer is typically needed to register that certain good or certain product has arrived into this warehouse. So into supply chain management, where we maintain the warehouses, we need some machine, we need some human being to report that this particular product has arrived into the warehouse. And if, for example, its quality is inappropriate, right? So if there is no trust in the operation of all these employees who are doing all the entries, or who are going to tell the arrival of any product or so, then the whole supply chain management, I assume that this is technically compromised, because any data can be supplied by a malicious writer. So there could be a malicious writer on the supply chain management, and he could compromise the complete chain if there is no trust on the operations of these employees. But on the other side, if we have all the writers who are trusted on the supply chain management, so blockchain is not needed, because here a regular database, again with some shared write access, they could be used. And we again have to answer this question to us, whether we actually need this this blockchain based solution for my supply chain management, where I am engaging my business into, or whosoever are writers there or readers there. So whether I have to go for this, or I can use a regular database in order to come up with my solutions. Now, multiple companies are there who are doing this. They are working on the research possibilities of getting reliable data. Now, this reliable, because this is a challenge. As I said, interfacing between physical world and this digital interface is going to create a lot of problems, a lot of issues. So how we are going to get reliable data from some trusted hardware into this blockchain, so that we can have a good connection between the digital and the physical world. So most of the companies, they are trying to do some research upon this, and they are looking for the solutions to achieve, to gain this reliable data from trusted hardwares, and then into their blockchain, so that they can connect the digital and physical world well. For as an example, we'll take one example, like let me take you to the example which has been used by the authors as well into the paper. So there is an example where some companies, they plan on using some trusted temperature sensors to record the temperature. So while delivering the food and while delivering the medicine, so we understand that there is some temperature which need to be maintained, and this temperature can be recorded through the sensors. So we have trusted temperature sensors which can record the temperature data during the delivery of food and medicine. And this data further can be used in smart contracts on the blockchain. Now, if the temperature sensors are assumed to be tamper proof, or they are not being hacked, or somewhere they have not been like compromised with, then there are several issues with such a solution. Because if we only assume that they are going to be tamper proof at all, they are not going to be compromised at all, so this may not like going to solve the several issues with this kind of assumption. So now we have to rely upon the temperature data. So a smart contract, as I said, will, this temperature data will be used by a smart contract on a blockchain later on. which is being treated as a trusted temperature sensor, which is recording the temperature inside that delivery truck, which is going to deliver food or medicine on way. So smart contract rely on temperature data, and it has to ensure that whatever key has been used to sign the data really belongs to the sensor which is being currently used for shipment, because smart contract is going to like use that key, and it has to ensure that the key which has been used to sign the data, it really belongs to the sensor, because there is a sensor suppose inside this truck, and there is a key which has been, like, after this we have to use this for smart contracts, and this key actually belong to this sensor. So this has to be ensured, that is currently used for this complete shipment, etc. So this can be solved with a sensible PKI based solution. We learned cryptography, etc. And then some checks can be they can be done on the client. We can check the clients to perform before storing this complete data into the smart contract. Now, the second and important thing is that a client has to fully trust the supplier for reliable data, because when you have suppliers in a supply chain management, so you rely upon the supplier for all kind of minimum maintenance of the transportation intricacies, like we have to ensure a specific temperature for delivery of some food products or medicines or so. So that way we have to rely that as a client, I have to always rely or fully trust my supplier for such reliable data, because the sensors can be easily tracked with, because even if we have tamper proof hardware, so we can always trick these sensors as well. Now, how the attack scenarios it takes place when we have so though there is a blockchain for this complete shipment or delivery, and we are trying to use the sensors data which has been recorded on the blockchain. Once recorded, we will always say that this is reliable data, this has not been untempered, this is immutable data, and whatever we have recorded on this blockchain is going to be a safe form of the data. But this is the actual attack scenario which could happen. So there is a trusted sensor which is there in a cooled compartment, while the rest of the truck is unrefrigerated. So you can see from this figure that this is a very, very simple attack on a temperature sensor. Now, how this temperature sensor is going to be attacked? So you can say that, for example, this supplier wants to save the cost by not cooling the complete delivery truck, and instead it will simply move the sensor into a cooled component or compartment, or say fridge refrigerator, while keeping the temperature of the rest of the portion in the truck to be unregulated. So this could be a very, very possible scenario. This is the intended solution. So we were looking for this intended scenario which was there, that supply truck is refrigerated and everything has been kept on this blockchain, and then the data at the end user side seems to be very, very reliable and safe. However, when we have this attack scenario, so we can see that this trusted sensors has not been kept into the complete to refrigerate or keep the complete portion of this delivery truck to be cool, or the temperature to be maintained, while this could be a very, very simple or possible attack scenario here. So the sensor definitely is going to record the correct temperature in the truck, which is containing all the items here. So a malicious supplier again can use this unrefrigerated truck, and it only cool down some small portion of this truck. So we have to understand that there are some intricacies when we use this blockchain based solution, and according to the structured methodology, whether we have to adopt for a blockchain based solution or not, and also depending upon all the agreements given or adopted by different companies who are providing this blockchain based solution, so whether we are going to adopt this or not. So this was about the supply chain management use case which has been taken up by the authors. So this is a complete article which also contains two more case studies upon the interbank and international payments, and there is one more case study on distributed ledgers. So once we go through this, we can understand that how we are going to answer this question whether we really want a blockchain or not, following this complete structured methodology, as well as we can also understand the complete guidelines or the complete solutions given by the different providers who give the blockchain based solution. So here I'll end, and I had these slides for you. So I have not put a lot of content on the slides because I wanted that you should go through this article which I'll be sharing, and then you can just look for the appropriate solutions there.